Now what I'm going to do is start talking about core data. Core data is a database feature in iOS. It's a local database. So I'm going to first of all talk about the database concepts, relational database, tables, column, rows, what they stand for, what they mean, give you an example, use a spreadsheet first of all to describe what I'm talking about, relationships, different kind of indexes and keys, and those concepts that are related to relational database. Core data is actually a as close as you can get to an object relational database. You actually work with objects. Before we get there, we need to understand relational database concepts. So basically, use core data. In one of the templates we'll come back after we discuss concepts is use this option when creating a new project. Use core data. It'll put in the infrastructure for us to use it. So right now I'm going to start with a spreadsheet and describe the concepts. A database is a collection of tables, one to many tables. Each table has columns, and columns would be like properties of the table. Let's say you have a employee. You want to keep track of employees in your organization. So one table would be an employee table. Maybe it's named employee. Now each property of the employee that you want to keep track of, you will create one column. Like it's like a spreadsheet. Like A, B, C is a columns going this way, and you have rows 1, 2, 3, columns this way, and rows this way. So basically that's what the one table would look like, columns and rows. So let's say I'm gonna start with a conceptual example. Let's say you want to keep track of employees and their evaluation. So we'll have one table called employee, another table called employee evaluations. For the employee, we'll keep track of first name, last name to keep it simple. And for the performance evaluation, we'll keep track of different kind of evaluations. Physical evaluation, psychological evaluation. So, and these two tables will be related to each other. Employee can have only one row, but one employee can have many evaluations, one every month or every 6 months or every year. So there'll be a one-to-many relationship. And I'll talk about all of this and explain all the concepts using this hypothetical example. Okay, so let's imagine we have a database called employee. We're going to keep track of employees and their performance evaluation. So I need two tables in there. One table is employee, table name is in green. Now I'm going to have many columns in there for each property that I want to keep track of about the employee. First name, last name, age. The naming convention is that you know how F is capitalized, N is capitalized. Two words, each word is capitalized. So that's the naming convention I'm going to go with. Now I need to uniquely identify each row. I'm going to come up with a scheme. I'm going to have a column called employee ID, and each value in it is going to be unique. I'm going to say the scheme I have is first letter of the first name, first letter of the last name, and since you know some of the time it could be the same, like Jane Doe, John Doe, JD, you know you can't have JD, JD. So I'll say you know JD1, the first one I encounter, the next one I encounter, and both of them end up in JD. I'll put 2 in there. Some kind of scheme here to keep them unique. And another column is ID. Usually every table, the database creates a table called ID, and it's called the primary key, and it's auto-generated. The database will automatically put in 1, and the next one will be 2, and the next one will be 3. It will automatically increment like a counter. So the ID column would be a primary key. A primary key has some properties. It's unique. Each row has a unique value. It's indexed behind the scene for quick searching. And if you are saying, well, if it's a primary key, is there a secondary key? Well, the employee ID, you could call it a secondary key because it's also indexed for quick searching. The indexed, the benefit of having a column indexed is fast searching. And the other property of employee ID I want here is unique. I want to put a constraint on it. Each value should be unique. If I accidentally put another one here called JD1, the database should complain and tell me you can't have duplicate values. So that's what these things are. The other constraints you can have are data types. ID is usually an integer. Employee ID, I have it as a alphanumeric, but it could be an integer. Age is an integer for sure. You cannot type. We don't want to allow anyone to enter alphabets into age column. That would be wrong. So for data validation, I have the data type. Last name, there could be a constraint on it saying no more than 50 characters allowed. So these are some of the things. Now other table is employee evaluation. Again, same scheme. ID, primary key, auto-generated, indexed, unique. And it has two columns. Evaluation date, evaluation. Evaluation date is data type is date. Evaluation is a string or character, string type. Employee ID, again, it's indexed. It's not unique in this table because you see there's JD. One employee could have more evaluations every monthly, yearly, or something. So it's not going to be unique. However, it's going to be indexed. So it's up to me when I'm designing the relation database to see what kind of constraint I can put on. Not unique in this case, according to my logic that I'm saying. Now, what is the benefit of this one? Well, employee evaluation and employee table are related to each other somehow based on employee ID column, this one to this one. For example, if I'm looking at a JD1, John Doe, how many evaluation does it have? I'm going to take this JD1 and I'm going to go over here. I'm going to find the employee ID column. I'm going to scan down. JD1, yeah, got a hit. This one, another one on this date. So how many evaluation does the user have? 2. Which ones? These 2. So there's the one employee has many evaluations. One to many relationship between employee and employee evaluation. Employee on the one side and employee evaluation on the many side of the relationship. If I'm looking at this table, it has a many to one relationship. So there are other kind of relationships, many to one, many to many, one to one. And I'll come back and explain those later, but this is the most commonly used, one to many. So here are two columns and some of the concepts. Now I'm going to switch over to Xcode, create a project, use core data checkbox. So the plumbing to create core data will already be there. And I'm going to jump in and create these two tables and see how to create them and how to create these indexes, primary key, link them together, and then start writing the code to insert, update, delete. Now I'm going to do a little practice working with the data designer. So when you have the XC data model, you click on that file with this extension, you will get the data model designer. It has different kind of outline, two different outlines. Add an entity, add an attribute once we have an entity, and there are two different styles of the editor. Table graph and also this kind where you see a little GUI designer. I'm just going to make a add an entry. So in order to add an entity like a table that we were talking about, let's make an employee and projects, and multiple employees can be working on the one project at any given time. So that's the basic idea. I need an employee table. So I click on add entity, and now I can type here. Just start typing. I'm going to call it employee, and I'm going to change my editor to editor style. Now I am going to, entity is selected. I can click here to add an attribute, or I can click here to add an attribute. I'm just going to click here because it's more intuitive for me. Employee has a name, let's say lowercase, a string type. I'm going to keep it simple. Of course, you'll have SSN and other things. Next entity, a table, I'm going to add is projects. And I'm going to add an attribute called project name. String type. Now I want to add a relationship between these two. There's one-to-many relationship. One project can be worked on by many employees at one time. So that's the basic technique. So I need to go to employee first of all, and I'm going to add a relationship. I'm going to call it projects. Projects relation. Destination. The other table, I mean the employee table, to the other one, not the employee. I want to add a relationship to the employee table itself. You see up there up on the employee is the entity I'm working on, so employee destination is projects, the other table at that point. See, no inverse so far because I need to go to the other table, projects, add a relationship. Now here I'm going to employee relation, destination is going to be the other table, employee, and is an inverse. Now the inverse, you see, I can have the inverse here, or I can go back to employee now and have employee relation. If I go to projects now, it automatically said projects relation. I hope I did it right. I can look at the editor style. Never mind, this is from early goof up. Okay, so that's pretty alright. The project is related to, I'm going to do it this way, employee on this side, projects on the other side. See, one arrowhead, one-to-one relationship. So if I go back to editor, employee, and say one-to-many, how will it look? Employee has many projects. No, that isn't right. I want it the other way around. So I'm going to have to uncheck this. I'm going to have to project employee relation. You see in here we need this box and click on the data model inspector. You see the inspector areas. We've been working with the other one. This we haven't done that so far in any tutorials, and now I'm doing this. Show the data model inspector. Click here, then this one-to-many relation. One project is being worked on many employees. Now if I look at the editor style, project, one project, many employees. So that's one-to-many relationship. a little example of how to work with this editor. Okay, so I'm gonna start all over again, create a new project based on that template. Then I'm gonna run it to see if it works. Then I'm going to go and modify the data model and create these two tables or entities as they call them, employee evaluation. In a employee has employee ID, first name, last name, age. Employee ID, evaluation date, evaluation. So let's do that. Okay, so the basic application looks like this. I'm gonna just created it based on the template. And basically it looks like this. There's just a table. I click on plus, it adds another time. Click on edit, minus, I'm going to shut it down. But basically it has an event table and it has a time step, and we have nothing to do with it. We'll get rid of all of that. What I want to do is I'm going to come in here, add an entity. And what was that? Employee. Now employee had some attributes. I'm going to switch over to this style. Some attributes. Employee ID. It was a string. Another one, first name, string, last name, and age. Let's go with int 16. Another entity was employee evaluation. This had attributes, employee ID, string, evaluation, string, evaluation date, type, date. And if I look at the other style, employee, I have employee evaluation. I'm going to go back in there and I'm going to go to the employee table and add a relationship to employee. I'm going to call it imp eval rel. I'm going to shorten it out because it's a lot of typing. Well, some may laugh, so I'm going to fully spell it. Employee evaluation relation destination, the other table, employee evaluation. Inverse, nothing so far. I gotta go to employee evaluation, add another relationship, call it employee relation, and it's in the employee table. Now I can actually do the inverse here. If I go back here, employee relation, if I go to employee relation, it is employee evaluation relation. So that if I look at the picture now, editor, you see now they are related to each other, one-to-one relationship. But each employee can have many evaluations. One employee, many evaluations. So we want to see two double arrowheads here. So back, employee, relationship, data model inspector, one to many, back in here again, yes. One arrowhead, two arrowheads signify many evaluations. One employee, many evaluations. So now we have one-to-many relationship. Now that's done right. Next, I'm going to look at the existing code of how many objects there are, and try to explain them. Objects, I mean within the code, how many classes are created. I'm going to get into. This tutorial is almost 20 minutes long. I want to keep them short. So I'm going to upload this as part 1, and in part 2 I'm going to continue further down the road. Thanks.